Hi everyone, we're part of RIT Racing, RIT's Formula SAE team on campus. Formula SAE teams design and build a Formula-style race car every year. Traditionally, these cars rely on a human driver to control steering, throttle, and braking. But what happens when the car needs to stop without a driver? Formula SAE is an international engineering competition where students design, manufacture, and race a small Formula-style car. Recently, competitions added a driverless class, where cars must operate autonomously. By 2030, this will be a required part of the American competition. One of the most critical systems enabling this is the driverless braking system, because the car must always be able to stop safely, even if everything else fails. Here's a video of one of our older cars performing a brakes test at competition to ensure it safely stops in case of an emergency. Now imagine if you could do it completely on its own.
This is where the driverless braking system comes in. Our starting point was the existing hydraulic braking system already in the car. Normally, the driver presses the pedal, which actuates the master cylinders and sends hydraulic pressure to the brake calipers. For driverless operation, we need a way to generate that same braking force without a driver. Our design focused on three key objectives. First, integrate with the existing vehicle without redesigning the entire braking system. Second, stop the car safely and reliably in all conditions. And third, ensure the system is fully compliant with Formula SAE and Formula Student driverless rules.
To accomplish this, we used a pneumatically powered piston setup actuated electronically with a solenoid. The core of our system is a pair of pneumatic boosters that used air pressure to generate hydraulic pressure, which actuates the vehicle braking system. This, along with a series of regulators, solenoids, and valves, allows us to remotely stop the vehicle just as a human driver would. The system is also fully redundant, so if one side fails, we can still ensure the vehicle still safely stops.
On top of that, the autonomous vehicle also needs a remote safety system to guarantee the car can stop at any point if something goes wrong. This is where the RSS, or remote safety system, comes in. The RSS allows for the remote stop of the vehicle at any point while it's driving, engaging the driverless braking system and stopping the car.
Here is a view of our full system in the chassis. The space claim blocks represent our solenoids, shuttle valves, and manual release valves, which control the generated pressure while also allowing for the manual override and control of the vehicle.
The manufacturing process of these components was all completed in-house in the KGCOE machine shop. While we did encounter some difficulties with difficult to machine features and tight tolerances, we were able to manufacture all required custom components to spec.
To validate the system, we performed extensive bench testing. These tests allowed us to verify actuator force, braking pressure, and response time before installing the system on the car. This step was critical for ensuring the system performs reliably when integrated with the full vehicle. Next steps for the system is to mount everything into the car and carry out full system level testing with the vehicle. This ensures that the system is reliable and is hitting all of our required performance metrics. And that'll conclude our lightning talk. We'd like to thank RIT Racing, as well as Professor Barrios and Professor Sherlew, for their support throughout the project. If you'd like to see the system up close, come visit our booth and check it out in person. Thank you.